The topic for today is scales of measurement. Scales of measurement. Measurement is the foundation of a research study. Everything a researcher undertakes starts with measurement. The mathematical properties of the variables we analyze are important because they determine which mathematical operations are allowed. This, in turn, determines which statistics we can use with those numbers. Statistical tests are applied depending on what scale the variable measures on. Now, scale of measurement is identification of the mathematical strength of your variables. So based on the mathematical strength, you decide on what tests you can apply on those particular variables or when you are studying those variables. Now, scales of measurement are rules that describe the properties of numbers. Variables have different numerical strength. Based on their numerical strength, a suitable scale of measurement is assigned to the variables under study. In all, scales of measurement are characterized by four properties: identity, magnitude, equal intervals, and absolute or true zero. So a variable might display 1, 2, 3, or all four of the properties. And based on its display of these properties, based on its numerical strength, we categorize the variable into one of the four scales of measurement. Now, what does identity means? Identity means that each number has a particular meaning. Magnitude means that numbers have an inherent order from smaller to larger. Interval means, or equal interval means, that the differences between numbers, that is units, anywhere on the scale are the same. For instance, the difference between 4 and 5 is the same as the difference between 76 and 77, that is 1. Absolute zero means that the 0 points or 0 point represents the absence of the property being measured. For instance, no money, no behavior, none of the options correct. So we'll be discussing all these properties and the scales of measurement associated in greater detail. So this is the diagrammatic view of the scales of measurement. It shows that the scales of measurement would work like a ladder, with properties being added as you move up the stairs. For instance, for the variable to be on ratio scale, it has to have all the properties of the scales below it. Nominal scale has got one property, identification. Ordinal has got two properties, identification and inherent order. So ordinal actually takes on the properties of nominal as well. Interval has got three properties, identification, inherent order, and one added property, equal magnitude. Ratio has got three properties, obviously one from nominal, one from ordinal, one from interval, and its own property of true zero. Now, what's nominal scale? It is the lowest scale of measurement. Values in the variable depict different categories. So this is important point that one should note, that before assigning any variable a scale of measurement, whether it's nominal, ordinal, interval, or ratio, one should clearly know that what values will this variable hold. A variable might hold different values. For example, what are the values for gender, male and female? What are the values for job rank, junior, middle, or senior ranked employees? What are the values for type of employment, permanent or, for instance, contractual? So based on the values that a variable will hold, we decide on the scale. Numbers are assigned to different categories while subjects are divided into various categories. In nominal scale, what we do is we assign numbers to the values that a particular variable holds. Now, nominal scales are most often used for or used as for qualitative variables in which observations are classified into discrete groups. For instance, gender. Gender has got two categories, male and female. Now, mathematical operations for nominal scale is mode, since we can only count the number of observations. So if a variable falls into nominal scale, the only mathematical operation that you can perform on it is mode, or mathematical operations that are based on mode. For instance, chi-square test. For instance, respondents of this study would be divided into male or female category, where the researcher could represent male by number 1 and female by number 2. Here, the assignment of numbers is mere identification of the categories for a variable gender. So in this case, or in nominal scale, the number that are used to identify the categories is just for mere sake of identification. These numbers that are used to identify the various categories in the variable or the various values in the variable, they actually do not have any other meaning to it. Data collected by a researcher shows that there are 50 males represented by category number 1 and there are 35 female represented by category number 2. Now what if we change their category numbers? What if we represent female by 1 and male by 2? So this will not have any impact on the data. We still have the same number of men and women in the data set. So for a variable to fall in nominal scale, the values in the variable are identified by a number, but this number does not depict any other thing except for identification. Which number is assigned to which category is completely arbitrary. Therefore, the only number property of the nominal scale of measurement is identity. The number gives us the identity of the category assigned. So each of the value in the variable is assigned a number, and that number assigned to the various values in the variable is just for the sake of identity. Another example of nominal scale variable could be country of an origin. So in this variable you can have values like USA or Pakistan. So I numbered UK as 1, USA as 2 and Pakistan as 3. I could have numbered it differently and that would not have made any difference. Here the numbers are only used for identification of the varying values. The country variable could hold. Okay, the varying values the variable could hold. Now, ordinal scale. Next on the ladder is ordinal scale. An ordinal scale of measurement is one that conveys order alone. So there is an inherent order in the values of a variable. So the numbers assigned to the values of a variable actually have an inherent order. An added property apart from identification. Now it's not just identification, it's not just that the numbers are used for identification of values. They have magnitude as well. They have got weight as well. This scale indicates that some value is greater than or less than the another value. There is an inherent ascending or descending order in the probable values a variable could hold. Suitable mathematical operations for ordinal scale is median, since the variable in this category have the property of order. Now, what variables could fall into this scale? For example, examples of ordinal scale include finishing order in competition. For example, first, second, third, or third, second, first, or class positions, first position, second position, or third position. Your level of education is in ordinal scale. For instance, you have done O levels, A levels, bachelor's, master's, MPhil, PhD, and your job rank, junior, middle, senior. Now, if we see, there is this variable, for instance, job rank, and it holds three values: junior, middle, senior. Now, in these values, there is an inherent order. It could be ascending and it could be descending. Now, these scales only indicate that one value is greater or less than the other, so differences between ranks do not have a meaning. So, the added property is the magnitude, the weight of the values that actually help us identify that, okay, which value is greater or less than the other. A researcher would like to collect data on education level of his respondent, and as we've seen, it could be matriculation, intermediate, bachelor's, or master's. And they could be numbered as matriculation for 1, intermediate 2, bachelor's 3, and master's 4. But here these numbers have got an inherent order with respect to the values. So you cannot move a number and assume that this will not affect the data. For example, you cannot move matriculation between intermediate and bachelor's. And you cannot assume that this does not have any effect on the data, because it does. Matriculation obviously is done before intermediate. Intermediate is done before bachelor's. Bachelor's is done before your master's degree. Now, changing the number assigned to different education level will disrupt the inherent order and will have serious impact on the data. A few other examples of the ordinal scale could include positions, first, second, third, job rank, supervisor, manager, or senior manager. It is important to note that with ordinal scale, the numbers assigned have an association with varying values. Now, the numbers that you associate or the numbers that you assign to these values, matriculation, intermediate, bachelor's, and master's, or maybe job rank, supervisor, manager, or senior manager, these numbers that you assign have an association with these values. So 3 is now associated with manager, 2 is now associated with senior, 1 is now associated with manager. You cannot move 2 to 1, 1 to 2, and assume that nothing will happen in your analysis, because it will. In identity, the numbers that you have assigned for identification were not associated with the values. But in ordinal scale, they are, because the values have got their own order. The next is interval scale. An interval scale measurement has the properties of identification, obviously, magnitude, and an added property of equal interval, equidistant scales, and no true zero. We will come back to no true zero in a minute. An equidistant scale is a scale distributed in units that are equidistant from one another. For example, the equal distance between scale points allows us to know how many units greater than or less than one case is from another. So we can always be confident that the meaning of the distance between 25 and 35 is the same as the distance between 65 and 75. Interval scales do not have a true 0 point. The number 0 is arbitrary. Now, in case an interval scale has a 0 value, in case there is a 0 value in a variable that you have put in interval scale, then that 0 would not be true 0. We'll discuss this in a minute. A good example of interval scale is the measurement of temperature on Fahrenheit or Celsius. The units on the thermometer represent equal volumes of mercury between each interval of the scale. The thermometer identifies for us how many units of mercury corresponds to the temperature measured. We know that 60 degree is hotter than 30 degree, and that there is the same 10 degree difference in temperature between 20 to 30 and 50 to 60. Now see the interval in your thermometer. So the distance between 20 to 30 is 10 degrees and the distance between 50 to 60 is 10 degrees. 0 degrees on either scales is arbitrary. So if there is 0 degree Fahrenheit or 0 degree Celsius, it's truly or completely arbitrary. It's not true 0, because at 0 the effect of the temperature is not absent. At 0 degree centigrade or 0 degree Fahrenheit, you will feel extreme cold. So the effect of the temperature is there. So this is not true 0. In order to have true 0, the effect should be null, nil, no effect. But here in case of temperature, if temperature is 0, it's pretty cold. Now other examples of interval scale could be age. For example, age is a variable. Now how do you classify age? In which category would age fall? Okay, now let's find out what values does age hold, because before doing your scaling you should know, or you should identify what values a particular variable can hold. Age can hold numbers. Now for example 21, 22, 23, 24, 25, so on and so forth. So the distance between age 21 to 30 is the same as the distance between 31 to 40, isn't it? So this is an equidistant scale. But can age store 0? Well, age can't be 0. So if age can't be 0, where does this scale, or where do you put in this scale? Obviously interval scale, because interval scale has got three properties. Identification, so age has got identification. You can associate numbers with age categories or age. It has got magnitude, obviously it has got weight. 21 is less than 22. There is equal interval. But now you would think that it hasn't got true 0. Well, true 0 or no true 0 in case of interval scale, or 0 as a value, this means that if a variable holds a 0, in order to put it into ratio scale, the value should be true 0. And if the value is not true 0, this falls under interval scale. This does not mean that a variable will have to hold a 0 and then we decide whether it's true or not. Or another example could be like a scale such as agreement scales or satisfaction scales. You can put them on interval scale. Now what is ratio scale? Which is on top of the ladder. Ratio scales are similar to interval scales in that scores are distributed in equal units. So they've got identification, they've got magnitude, they've got equal interval, but one thing that is added onto ratio scale is their true 0. They have all the properties of abstract number system. These properties allow us to apply all the possible mathematical operations: addition, subtraction, multiplication and division. Now in this case they hold true 0, absolute, and this allows us to know how many times greater one case is than another. For variables on ratio scale, order is informative. This is an ideal scale in behavioral research because any mathematical operation can be performed on the values that are measured. Common examples of ratio scale include money in the bank, return on investment, number of children, and years of education. For example, a person earning 20,000 and another earning 40,000. So we could easily say that second person is earning twice as much as the first person. However, in case of interval scale, if we take the example of temperature, we cannot say that 40 degrees centigrade is twice as hot as 20 degrees centigrade. Ratios are informative on this scale because a true 0 is defined. It truly means nothing. So a 0, a variable, when holds a 0, and if it means that the 0 means no effect, you can put it into a ratio scale. Hence, it is meaningful to state that 60 pounds is twice as heavy as 30 pounds. Here's the summary. So a variable on nominal scale will only have the properties of identity. A variable on ordinal scale will have identity and magnitude, and the mathematical operation that you can perform is just rank and order. The measure of central tendency is median. In interval, the variable will have the property of identity, magnitude, equal interval. The operations that you can perform is addition and subtraction. The measure of central tendency is mean. In ratio, you've got identity, magnitude, equal interval, absolute zero. And the operations, all different mathematical operations can be performed. And the measure of central tendency is mean. Now, let's see a few examples. I've got a whiteboard here and I'm going to do a few examples for you. So what we were talking about is that, okay, a variable can be classified into 4 scales. So anywhere in the world, a variable or any variable in the world can be classified as nominal, ordinal, interval, or ratio, one of the 4. But obviously if it's on a ratio scale, this means that it has got all the properties of nominal, ordinal, and interval. So what's the first step when you see a variable and you want to classify it, or you want to identify its scale of measurement? Now the first step is that you identify its values, the probable values that it will hold. For instance, let's say we've got a variable color. Okay, now there are different colors. Let's say there could be red, there could be green, and there could be blue. Now this is a variable that can hold, or that holds, different colors. So what are the values that it could hold? Maybe red, green, or blue. So first step done. Now the second step is you put in, or you use, the second step is that you use a number to identify these values. In this case, I put in 1, 2, 3. So the color red is identified by number 1. The color green is identified by number 2. The color blue is identified by number 3. Okay. So the property of nominal scale is done. So yes, obviously we can put this variable color as nominal scale variable. But now since the property of nominal scale is done, we can check this variable color for ordinal scale, and we can see whether it has got an inherent order or not. Now in this case, if we see, there is no order in red, green, or blue. You could have put blue here, you could have put red here, and you could have put green here, or maybe green here, and this would not have made any difference. But let's say another example. Let's say we've got a variable position, and position is first, second, and third. Let's say we identify first with 1, second with 2, and third with 3. Now there is an inherent order here. The numbers obviously are used for identification, but these values have got an inherent order as well. You cannot put third here and you cannot put first here. So there is an inherent order. Now both the properties of ordinal are satisfied. So now we'll check this variable for interval, whether we can put it on in interval scale or not. So let's say the boy who scored first position had 50 marks, the boy who scored second position had 40 marks, the boy who scored third position had 20 marks. Now what's the difference between first and second here? It's 10. What's the difference between second and third? It's 20. Now the distance between these two and these two is not equal. So you cannot put this position variable into interval scale. Now let's see another example. For instance, let's say we've got age. Maybe we've got different ages: 21, 22, 33, 44, 55, so on and so forth. Now what we could do is, if we look, age can have numbers. For instance, if we are collecting data from people who are working somewhere, age could have values from 18 to 65. So whenever you see a variable that can hold multitude of values, several numbers, the first question that you should ask yourself is, can I classify or can I create groups? Yes, in this case, for age, you can create groups: 21 to 30, 31 to 40, 41 to 50. Now, I use 1 to identify this group, 2 to identify this group, 3 to identify this group. Now, if we see, okay, identification is done, so nominal scale is done. Let's see, or let's interpret or evaluate it for ordinal scale values. Yes, this 21 to 30 is less than 31 to 40. This 31 to 40 is less than 41 to 50 here. So there is order. Is there is equal magnitude? Because now that order is done, we have to check it for equal magnitude. So once you keep passing the properties of one scale, you have to move to the other scale. In this case, the distance between 21 to 30 is 10, 10, 10. So the property of equal magnitude is obviously done. But next, obviously, once you have got it on interval scale, all three properties are done. Now you have to check it for ratio scale. Does this variable hold a true zero? No, because age cannot be zero. The next statement or the next example, let's say we've got a variable return on investment. I've invested, say, 1000 rupees. So what if I invest 1000 rupees? I could lose all of it altogether. So I do not get anything. I could get 1 rupee. I could get 10 rupees. I could get 10,000 rupees. So it could be any values. And as I look at this variable, I can obviously classify this variable or create classes. It could be from 0 to 5000 and 5001 to 10,000. So we use 1 to for this particular class and 2 for this. Now there is an order. Obviously there is an order. This class 0 to 5000 is less than 5000 to 1000. Does they have equal magnitude? Yes, this is 5000, this is 5000. Now the last property, once it has satisfied all the three properties, the last property that we want to evaluate is whether or not return on investment can hold a zero. Yes, it can hold a zero. What if you invest somewhere and you do not get any return out of it? All of it is lost. So obviously return on investment here can hold a zero. So this is how you can categorize your variables into different scales of measurement. Thank you.